Hello, once again, welcome to Online Math Tutorial. Today, we'll be treating partial fraction. Now, the idea behind partial fraction is this. I know we are common with, we know this. Let's say we have something like x over 2 plus 2x all over 3, and we are asked to add this problem. Let's say we are given simplify x all over 2 plus 2x all over 3. What do we normally do? What we will do here is to look for the LCM of the denominators. The LCM of 2 and 6 is 2 and 3 is 6. So we now say if 2 divides here, it will give us what? 3. Then we use 3 to multiply the numerator, which is x into 3 plus, we use 3 to divide 6, and that will give us 2. Then we use 2 to multiply the numerator, which is 2x into 2. So, and this will now give us x times 3 will give us 3x plus 2x plus 2 times 2 will give us 4x all over 6. And this is equal to 7x over 6, which we can still break down further to 1 whole over x over 6. So, this is addition of fraction where we combine two fractions in order to get this. So the idea behind partial fraction is you solving from here back to this point. What you did in addition of fraction is to solve from here to here. But in partial fraction, you'll be given a single fraction for you to break it down into parts. So that's why it's called partial fraction. We are going to break down a single fraction into different parts. So that is the idea behind partial fraction. Also, there are different types of partial fraction which we are going to treat in the course of this class. One of them is non-repeated linear factors as the denominators. Partial fraction in this one where the denominators are linear expressions and they are not repeated linear expressions. So that is one of the examples which we are going to look into. We are also going to look into different other types of partial fractions at the course of this class. So let's solve this problem in order to break down this fraction into different parts. So what we say, we now have solution. Solution, we say 7x plus 19 divided by x plus 1 into x plus 5. So what we do here is to assume that this fraction will be broken down into two parts. So we'll say that this fraction, to break it down, that it should be equivalent to a all over x plus 1 plus b all over x plus 5. This idea is coming from when we have something like the example I give, x all over 2 plus 2x all over 3, where we will get the LCM. The LCM is 6, which is the same thing as writing 2 times 3, writing it differently. So here we are implementing this same thing here in case we have something like this. So we can break this down here as A all over the first linear expression plus B all over the second linear expression. So what do we do here? This will now be equivalent to we look for the LCM of this and this, which is same as x plus 1 into x plus 5. Now, applying the same thing, we use the denominator here, to divide this LCM. We use this to divide the whole of this, and when this cancels here, we'll be left with x plus 5. So we use x plus 5 to multiply the numerator, which will now give us a into x plus 5. This idea is coming from the example I gave you, x all over 2 plus 2x all over 3. When you get the LCM, which is 6, use 2 to divide here to give you 3. Then x times 3 plus, use 3 divided to give you 2. Now 2x plus times 2. That is the same thing we are doing here. We use this x, divide this, you'll be left with this. And use this to multiply the numerator. That is how to add two fractions together. Plus, use this to divide the whole of this. You'll be left with x plus 1. And x plus 1 multiplying the numerator, we have b into x plus 1. So this is equivalent to, so we can say that 7 all over 19 divided by x plus 1 into x plus 5 is equivalent to, open up this bracket. If we open this bracket here, we'll have a times x will give us ax, plus a times 5 give us 5a, plus b times this will give us bx, and b times 1 will give us plus b, divided by x plus 1 into x plus 5. So when you look at this, you find that the denominators are equal. Since the denominators are equal, this means that the numerators are also equal. So that means we can equate these two, the numerators, to the numerator of this other side. So we have that 7x plus 19 is equal to, we can collect like terms by bringing the ones with x, we bring them together. So we can have a plus b all into x, then plus 5a plus b. A and this, we collected like terms. The like term there is x. That's why we have it here. So we can equally open this bracket, or I have ax plus bx. So this, since this is equivalent to this, since this is equivalent to this, meaning that this also means that this one with the variable x is equivalent to 7x, and this other side, which is the constant part, is equivalent to 19. Listen, this has x, the variable x here is equivalent to this, and also this other side, 5a plus b, is only a constant. It doesn't have any variable, means that it is also equivalent. Okay, at this point we will look at the variables. The ones with the variable here is x. The variable here is x. So we can say that a plus b is equal to 7. These are equation 1. And for the constants, those without x, we have 5a plus b is equal to, the constant here is what? 19. So we can call this equation 2. So with this, you can use either any of the method in simultaneous equation, either elimination method or substitution method, to solve this problem at this point, in order to get the values of a and b. So let's use elimination method to solve this. So using elimination method, we can say subtract equation 1 from equation 2. So meaning, if you're subtracting equation 1 from equation 2, that means this should be on top. We can now say that 5a minus a will give us 4a. b minus b will give us 0 equals 19 minus this will give us 12. So since we have 4a equals 12, this means that a will be equal to 12 all over 4, which is equal to 3. So a is equal to 3. So we can substitute for a in equation 1. So we can say substitute 3 for a in equation 1. So if we substitute this for a here, we have that b will be equal to, this cross equality sign, we have 7 minus a, and that should be equal to 7 minus 3, which will give us 4. So this means that your b is 4. We are not done yet. So the partial fraction for this, all we need to do now is to replace the values of a and b in this expression here. So we can now say that 7x plus 19 all over x plus 1 into x plus 5 is equal to, substitute for a. We got a as 3. So we have 3 all over x plus 1 plus 4 all over x plus 5. So with this, we have broken down this fraction into its parts here, which is 3 all over x plus 1 plus 4 all over x plus 5. Thank you for watching. If you find this video helpful, please kindly subscribe to this channel so that we'll be dropping more videos for you. Thank you.